Welcome to our exploration of lighting control within building management systems, or BMS. In today's world, efficient lighting isn't just about flipping a switch, it's about smart automation, energy savings, and creating comfortable environments. Lighting systems are a major contributor to a building's energy use, especially in commercial and industrial settings. By integrating lighting control into BMS, facility managers can automate schedules, optimize energy use, and enhance occupant comfort. In this video, we'll break down the architecture, components, control methods, and energy-saving strategies that make modern lighting systems both intelligent and sustainable. Let's begin our journey into the world of smart lighting control. So, why is lighting control so important in modern buildings? The objectives are clear: reduce unnecessary energy consumption, improve comfort and productivity, and enable flexible lighting scenes for different spaces. Automated systems can turn lights off when not needed, adjust brightness for optimal comfort, and even support demand-based load shedding. Integration with other building systems like occupancy sensors, fire alarms, and daylight sensors ensures that lighting responds intelligently to real-time conditions. Ultimately, lighting control isn't just about saving money, it's about creating smarter, safer, and more adaptable spaces for everyone. Let's take a closer look at the essential components that make up a lighting control system. At the heart are the light fixtures. These can be LED, CFL, fluorescent, or smart fixtures. Switches and dimmers, whether manual or digital, allow for basic control. Occupancy sensors detect human presence, while daylight sensors measure natural light to adjust artificial lighting. Lighting relays and dimming controllers handle the switching and dimming of circuits. All these elements are managed through lighting panels and a user-friendly control interface, often integrated into the BMS. Together, these components form the backbone of a responsive and efficient lighting system. Lighting control architectures generally fall into two categories: centralized and distributed. In a centralized system, all lighting circuits are wired to a central panel and controlled by a BMS controller, ideal for large buildings with dedicated infrastructure. Distributed control, on the other hand, places controllers or smart switches in each room or zone, communicating over protocols like BACnet, KNX, or DALI. This approach is often used in retrofits or modular buildings. The choice between these architectures depends on building size, complexity, and future flexibility needs. Manual control remains an important part of lighting management. Facility staff or users can operate switches or use a graphical interface to control lights as needed. However, time-based scheduling takes automation to the next level. Lights can be programmed to turn on or off according to predefined schedules. Think of corridor lights shutting off at 10 p.m. every night. This not only saves energy, but also ensures consistent operation without relying on human intervention. Combining manual and schedule control provides both flexibility and efficiency. Occupancy-based control uses sensors to detect when people enter or leave a room. For example, passive infrared, PIR, or motion sensors can automatically switch lights on when someone enters and turn them off after a set period of inactivity. This approach is especially effective in areas like restrooms, meeting rooms, or storage spaces where lights are often left on unintentionally. By responding to real-time occupancy, these systems significantly reduce wasted energy and ensure that lighting is available only when needed. Daylight harvesting is a smart technique that adjusts artificial lighting based on the amount of natural light available. Lux sensors measure ambient light levels, and when sunlight is sufficient, the system dims or turns off artificial lights to save energy. For example, if ambient light exceeds 500 lux, lights may be dimmed to 40%. This not only reduces energy consumption, but also maintains a comfortable and consistent lighting environment for occupants. Daylight harvesting is especially valuable in spaces with large windows or skylights. Scene-based control allows for predefined lighting settings tailored to specific activities or events. For example, a meeting room might have a presentation mode with dimmed lights at the front and brighter lights at the back, or a cleaning mode with all lights at full brightness. These scenes can be activated with a single button or automatically based on schedules. Scene-based control enhances flexibility, supports various activities, and ensures the right lighting for every situation. Dimming control is essential for both energy savings and ambiance. There are several methods. 010V analog dimming uses a control voltage to adjust brightness. DALI, digital addressable lighting interface, provides digital dimming and individual lamp control. DMX 512 is popular in stage lighting. And PWM, pulse width modulation, is used for precise LED dimming. Choosing the right dimming method depends on the type of fixtures, desired control granularity, and integration needs with the BMS. Integration is key to unlocking the full potential of lighting control. Lighting systems can connect to the BMS using protocols like Modbus for basic relay control, BACnet, IP for smart controllers, KNX for automation zones, and DALI for individual lamp addressing. The BMS graphical interface allows facility managers to monitor room-wise lighting status, real-time occupancy, energy usage trends, and even detect faults like lamp failures. This centralized visibility and control make building operations smoother and more efficient. Maximizing energy efficiency is at the core of modern lighting control. Strategies include automatic switch-off to prevent unnecessary usage, combining occupancy and daylight sensors for maximum savings, and grouping dimming zones to optimize lighting based on space use. Integration with energy management systems, EMS, enables participation in demand response programs, while time delay controls ensure lights remain on briefly after a space is vacated. These strategies collectively drive down energy costs and support sustainability goals. Emergency and safety lighting is a critical aspect of any lighting control system. These lights must operate independently of normal schedules and remain functional during power outages or emergencies. Controlled via separate relays and monitored by the BMS, emergency lighting systems are checked for battery faults, failed test sequences, and lamp failures. Compliance with local fire and safety codes is essential to ensure occupant safety at all times. Continuous monitoring and timely alarms are vital for maintaining lighting system reliability. The BMS can detect lighting circuit failures, lamp burnouts using current sensing, relay module overloads, and even tamper alarms if a panel door is opened. These alerts enable quick response and maintenance, minimizing downtime and ensuring that lighting remains safe and effective for building occupants. In summary, lighting control within BMS is about much more than just turning lights on or off. Through advanced logic like occupancy detection, daylight harvesting, scheduling, and dimming lighting systems can significantly reduce energy consumption while enhancing comfort and safety. Integration with BMS provides facility managers with powerful tools to monitor, optimize, and maintain lighting across the entire building. As we move towards smarter, greener buildings, lighting control stands out as a key contributor to both sustainability and operational excellence.